Okay guys, the topic of this video is null and alternative hypotheses and how we set these things up. From the previous video of the reasoning behind hypothesis testing, we can see that the purpose of the null and alternative hypothesis is to officially state what we want to test. And it's the it's extremely important to get started in the right direction, because we're ultimately going to teach you how to make a final decision. And the final decision is with respect to what we officially set up in the null and alternative hypothesis. Now, from the previous video, the notation that we'll always use for the null hypothesis is H sub 0. And from the previous video, hopefully you remember that the notation that we set up for the alternative hypothesis is H sub A. Now, moving forward, more general terms, guys, the null hypothesis will always be H sub O and a colon, and a box equal a box. In the first box is going to be our parameter. Guys, for your all's sake, the parameter will either be mu or p. And in the second box, it will be the value that the claim has been made. For example, the previous video, we said someone makes a claim that the average wait time at Tim Hortons is 3.2 minutes. In that case, we would put a 3.2 in for the value. The other I think I used is 12% of Ohio State University students are UK fans. In that case, our value would be 0.12. Once we get the null hypothesis set up, then we set up what's called the alternative hypothesis. And in this case, we have another box and another box. And whatever comes here is when the first box will drop down to the first box for the alternative hypothesis. And whatever comes here, the value will be the value in the alternative as well. So the parameter and the value. Now, what goes in next is the motivation for our test. And in this case, we're going to set up our alternative hypothesis with one of the following symbols. All right, let's look at an example. A university administrator makes a claim that the average ACT for entering freshmen is 24. So that's our claim. So without question, we have H sub O colon, box equal box. What goes in the first box is our parameter, and that's either going to be mu or p. And since the claim has been made about an average, we should know by now that that's going to be represented by mu. The second thing is the value, which is 24. Our alternative hypothesis will always be the same parameter, and it will always be the same value. What goes in next is the motivation for the test. Greater than, less than, or not equal to. Now guys, typically when we're setting up alternative and null hypotheses, we don't use the boxes. Those are just kind of teaching tools. And our null and alternative will look something like this. Now, next page, let's assume that the motivation for the test is we feel, after speaking to a small group of students who will be entering as freshmen next year, who have ACTs higher than 24. So our motivation here for our test is we feel that the average ACT is higher than claimed. So gang, our null, our alternative, would look exactly like this. So the motivation, we think it's higher, therefore we'd use greater than in the alternative hypothesis. Insurance companies have made the claim that the average homeowner's claim is $275. You suspect this? You think that they're inflating this claim average, this average amount, so they can charge more money. You feel that the average is lower than $275. Okay, set up the null. What's the motivation for your test? $275. So we think the claim is less than $275, so we're going to put less than. University administrator claims that the mean SAT for entering freshmen is 1,200. Another administrator suspects the claim. Operative word here, guys, suspects. Now, suspects doesn't have, to me, an indication of suspecting whether it's higher or lower. They just have a situation where they suspect the 1,200 and would simply like to test it. As in situations like that, we do what's called a two-tail test, a not equal two-tail test. So if there's not an implied direction of greater than, less than, more than, higher than, lower than, the default is not equal to. And guys, what I mean by default, it's what we use in all tests of hypotheses if a direction isn't specifically and clearly implied. Gallup poll reports that 32% of people believe in ghosts. You suspect the claim and you'd like to test it. Our null hypothesis, H sub O. Guess since a claim has been made about a percentage, we're going to use P. And we'll always put this as a decimal. Our alternative hypothesis, again, always have the same letter, always have the same number. And then we'll choose from the one of the three inequalities that coincides with what we would, with the motivation for the reason we're testing. Well, guys, suspect to me doesn't imply we think it's higher, we think it's lower, just a general motivation for a test. So hopefully you see by now this is called a not equal to test. So gang, in summary, we're going to have in this class either mu or p equal to some value. In our null hypothesis, and our alternative hypothesis will be mu or p not equal to, greater than, or less than, depending on the motivation for the test. Now guys, taking this to the next screen, if our alternative hypothesis is not equal to for reasons that we'll teach you later on, we refer to this as a two-tail test. If we choose as the motivation for our test, either, well, that may be the ugliest one in the history of writing ones. If we choose greater than or less than in our alternative hypothesis, then we refer to that as a one-tail test. All right, gang, that's it. Have a good one.